Okay, good morning, everybody. Right at the moment, it's Monday morning. You'll probably get this Tuesday morning. But if you're watching this, we're going to start Chapter 12. And some of you did an outstanding job in Chapter 11. Great job with all the pictures and stuff and things you did. Hopefully doing those things, maybe in the future you can actually remember those and see a use for them. Right now you probably don't see a use for them at all. But hopefully sometime in the future you will. So now we're going to talk about probability. And probability is an extremely useful tool. It is used in just about every type of statistic that's being used out there. What's the probability that the COVID is going to do this or that? And so probability is a big thing. So what we're going to do in this chapter is really kind of do the basics of it and make sure that you understand certain things. Again, you can do the problems that are on the assignment sheet. And I think Chapter 12, Section 1 is not on the assignment sheet. So let me tell you what it should have been. There's different things you can do, okay? So pay attention. If you want to do the assignment sheet pages versus what I'm going to, the lighter assignment that I'm going to give you, then the assignment sheet pages would be 12.1, page 672, and that's going to be problems, let's do 3 through 15 odds. Okay, and as always, you're required to make sure that you look at the answers. And then 12.2 is on the homework page, but I'll just put it on here, page 680, and that's 3 through 19 odds. Okay, so you can do all those, or you can watch this and do the simple assignment, okay? All right, so let's get started with what probability is. Basically, what you're saying is, what is the chance that you're going to get a certain result? All right, so the chance part is what I want to talk about real quickly. It can be written either as a percent. Hey, he's got an 80% chance of making this free throw. Or I'm going to flip this coin, and it's 50-50. It's 50% chance that I'm going to get a heads, or 50% chance I'm going to get a tails. Or you can say that's 0.5. You can write it as a decimal. Or 1/2, 1 out of 2. The possibilities over the total. So how many heads are there on a coin? Well, there's one head, and there's two possibilities, heads or tails. Okay, so that's why it's 1/2. So that's where probability comes from. So that's 0.5, or you could say that's 50%. You move the decimal 2 places to the right. So 3 different ways you could write your answers. Okay, so now a different way that you could write some things. So we're going to use a tree diagram, or I'm going to put it on its side here. So let's say we flip a coin. The first possibility is you can have a heads or a tails. So this is the first toss. And then you have the second toss. You can keep going with this. So let's say we have a heads on the first one. On the second one, we get heads or tails. And the same thing if I had tails on the first one. I could get heads or tails on the second one. And then you could have a third toss. Okay? And again, each one of these then has 2 possibilities from those. Heads and tails, heads and tails, heads and tails. Okay, so that's how you do a tree diagram. Now, what are all the outcomes then? So the end result. So what we do here is that would be heads, heads, heads. This would be heads, heads, tails. And hopefully you've done this before. You should have done this before. It's okay if you don't remember, because this is what you need to be learning at the moment. And we keep going. This is tails, heads, heads, and tails, heads, tails, 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 head, and tails, tails, tails. So how many total outcomes are there after 3 tosses? You have 8 total outcomes. All right, so what's the probability that if I toss a coin 3 times, that I'm going to get all heads. So we write this like this. What's the probability that I'm going to get all heads? That's how you officially write probability. Well, again, if you look up at how we do probability, then the possibilities, how many possibilities are there of getting 3 heads? Well, there's only one possibility of getting 3 heads. Out of how many? The total, 8. So if you flip a coin 3 times, you're going to get 3 heads 1/8 of the time. So if you use your calculator and do 1 divided by 8, that is 0.125. Move the decimal 2 places. That's 12.5%. 12.5% of the times you're going to get all heads. Okay? Excellent. So that's probability in a nutshell. So let's just do a couple of other, or maybe one other example here, and then we can talk about some other things. Let's use cards for the next one. So how many cards are in a deck? There are 52 cards in a deck. There are 13 hearts. There are 13 diamonds. There are 13 spades, and there's a reason I'm doing these, and 13 clubs. Okay, so some of the easy experiments I'm going to have you do, easy assignment I'm going to have you do, you might have to do some of these things. So hopefully you have dice or coins. Usually everybody has a coin or something they can flip. You don't even have to use a coin. And you can use a bottle to spin. Just for instance, off the side here, you could spin a bottle. You know, draw a let's see, Mountain Dew. Spin a can or whatever, and you make a paper. And you have this paper, and you draw this on. You spin this Mountain Dew can or whatever, and you have all these numbers on it. So I'm just kind of giving you a heads up of what I'm going to be having you do. I don't know. So we're going to do some things like that for your simple assignment. Okay, so cards. You have 52 cards in a deck. There's 13 hearts, 13 diamonds, 13 spades, 13 clubs. So instead of saying my first draw, I'm not actually going to do all of this. I'm just going to start to write it down here. How many possibilities are there for the suits? These are called suits, okay? So there are hearts, there are diamonds, there are spades, and there are clubs. And that's the first draw. You have a possibility of getting all of those, all right? So now what's the second draw? Again, the same thing. There's 4 different possibilities. So each one of these, you got to draw four lines coming from them. And you can see how quickly this is going to be very, very messy. So how can we figure all these things out and get the same amount of information mathematically without actually drawing these things out? So you have all these different possibilities here. So how do you get the total number of possibilities in your fraction? If you go back and look at your coins, you had 2 possibilities, heads or tails, in the first draw. You had 2 possibilities in the second flip of the coin, and you had 2 possibilities in the third flip of the coin. Well, that equals 8. So instead of drawing it out, it's called the fundamental counting principle. You just multiply how many possibilities each time you do it. So in this case, what do we have? We have 4 possibilities for the first draw. We have 4 possibilities for the second draw. So the total amount that we would have, there would be 16 as my total amount here. If you think about it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 end results. That's how you get your denominator if you're wanting to do something without drawing it all out. I'm actually going to have you draw something out for one possible problem and then have you do another one for something else. Another thing is in each of these suits, you have all the different numbers. If you do 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and if you put the ace at the end there. So you have all those different cards. There are 13 of those cards. and there's 13 in each one. Well, if you just said, what's the probability of getting a jack of clubs? Well, how many jack of clubs are there? There is one jack of clubs. Out of how many possibilities are there? There's 52. So the probability of drawing a jack of clubs is 0.0192. Move the decimal 2 places to the right, and that's 1.92%. So if you play cards a lot and you're playing with a full deck, and you really want the jack of clubs or one other card that's specific to a suit, you have a 1.9% chance of actually drawing it. So it's a very small probability of you getting those things. And the whole point is to show you how to figure these things out. You don't want to make a bet with somebody if you don't know what you're doing. All right, so let's move on from here. So now let's combine these two. We're going to toss a coin, heads or tails, and we're going to draw and try to get a heart. Okay. So what is, so we have hearts, clubs, spades, and diamonds. How many possibilities are there? What is our denominator? Well, you have 2 possibilities here, and you have 4 for your suits. So remember, 2 times 4, there's going to be 8 possibilities. And if we were to actually draw them out, hearts, clubs, spades, and diamonds, what is our outcome? And that would be heads and a heart, and a heads and a club, heads and spades, heads and diamonds, tails and hearts, tails and clubs, tails and spades, and tails and diamonds. All right, so now the question is, what are we asking for? What do we want? And it's the total possible of what it is we're asking for. That's how you get your numerator. The bottom is the absolute total possibilities, all of them. There are 8 of them. But what is it that we want? Well, let's say, I would like to get a heads and a spades. So we write it heads and spades. Well, how many heads and spades are possible? In this case, there is only one possibility of getting a heads and a spades. Okay? So that would be 1 out of 8 again. Sometimes you're going to have multiple possibilities. And you're only going to do 1 draw or 1 flip of the coin. That doesn't mean that the top number is a 1. It means you have to put how many possibilities of what it is you're wanting at the top, even though you're only going to do it 1 time. Okay? All right. So this is the next thing I just want to show you real quickly is about geometric probability. So let's just make a picture here, and we are going to let's do something different. Let's make it easy. We're going to take our paper and we're going to divide it into 6 sections. All right, so we'll just, for the ease of this, we'll call this an 8 by 12 sheet of paper. All right, now you're going to need to do something specific. Make sure you measure it accurately, but for the sake of the problem, I'm just going to do this one. So that means this is 4, and these are 4. These are all 4 for these vertical sides, and if we do it evenly, these are going to be 4. Well, I didn't really want that either. But for the sake of this, let's just do this way. So what's the area of each one? The area of each one is going to be base times height. That's 16. Each of these is 16 square units. Okay? And we'll call this the blue section, and the green section, and the white section, and the purple section. And let's do whatever, brown and yellow. Okay, what is the probability that if I toss a coin onto the sheet and get in the brown section? Okay, well, it is the area of what you want over the total area. Okay, well, I want the brown area, so that's 16 over the total area. What's the total area? Well, 8 times 12 is 96. So 16 on your calculator, take 16 divided by 96, and that's 0.1666666. Okay, so that is, we're just going to make it easy, 17% possibility that when you flip a coin onto the paper, that it's going to be in the brown section. Okay, 17%. Looks like it'd be a lot more than that, but it really is only 17% chance. Which, by the way, since they all have the same area, you could just say there's 6 possibilities, and the brown is 1 possibility. 1 out of 6 is still the exact same probability that what we have here. So what I am going to want you to do is probably change those areas. All right, now, in a minute, I'll tell you what I want from section 1. Okay, let's talk about section 2 real quickly. Section 2 is called Conditional Probability, and it means it's really asking about independent, and this will be a lot faster since we already know probability now, versus dependent. Okay, so independent events means that one thing doesn't depend on the other, and then obviously dependent events means that the second thing depends on the first thing. The first thing never depends on the second thing. The first thing is totally independent. So what am I talking about? Let's use 2 examples here. If I flip a coin, I have the possibility of heads or tails on the first toss. The second toss, I have a possibility of getting heads or tails again, right? Well, did the second toss have any, does it carry any weight? Is it dependent on what I got on the first one? No, it doesn't depend on it at all. It's totally independent from the first toss, because you're still going to get heads or tails the second time you toss it, the third time you toss it, the 100th time you toss it. The 100th toss does not depend on what you got on the previous 99 tosses. You still have a possibility of getting heads or tails. Versus, all right, so this is an independent possibility. Let's draw, let's put all the cards on the deck, 52 cards, all right? And let's take the first draw. And we want a heart. What's the probability of getting a heart? Well, there are 52 cards and there are 13 hearts. So that's 1/4 or 25%. Okay? Now, if I put the card back, the second draw to get a heart is going to be the exact same probability. But if I say without replacement, and that's a key phrase that they use a lot, that means, and you are to assume you actually drew what you wanted on the first draw. You always are to assume that you drew what you wanted on the first draw. The second draw, that means there's only 12 hearts left. And there's only 51 cards left because I didn't put the card back in it. This is called dependent. The second draw depends on the first draw. All right, so how do we do this? This is a multiplication. If I draw, what's the probability of getting a head and a head? Okay, we already found that out. That was 1 out of 4 if you flip it twice. Okay, which the probability, what this is the probability of a heads, and then you toss it again, the probability of a head. The and means multiply, or for later purposes means plus. So and is what we're asking. What's the probability of getting a head and a head? Okay, well, the probability of the first head is 1/2. The probability of the second head is 1/2. There's 1/4. So I'm teaching you different ways of coming up with the probabilities by mathematically doing it. Same thing with the cards. The probability of drawing a heart without replacement and the probability of drawing another heart. Well, the probability of drawing the first heart is 1/4 times the probability of drawing the second heart without replacing it is 12 out of 51. So 1 times 12 is 12, and 4 times 51 is 204. And we can reduce it or just take 12 divided by 204, and that would be 0.0588 or 5.8%. 5.8% for you to draw 2 hearts in a row from a deck of 52 cards. All right, so here's what I want you to do. Okay. For 12.1, you can do the assignment, or you can do this. You can do problem number 3 on paper. You roll a die and you flip with 3 coins. And if you do problem number 3, then you actually need to do what it says. I want you to roll a die and flip a coin 3 times. All right? And tell me what you get. So I want the diagram, okay, and whatever for your 2 things. So you're going to roll the die. There's 6 numbers on a die, and then you flip a coin. So I want you to draw it out and actually tell me what the probability of what are all the possible outcomes. List them. Okay, so if you draw this on your paper, you'll actually have it all listed. But remember, go ahead and list the outcomes at the end. Don't just do this part and this part. Make sure you list the outcomes that you got at the beginning, okay? Then what I want you to do is I want you to actually roll the die, take a die, roll it, and then flip a coin 3 times and write down what you got. All right, so that's the first problem from 12.1. The second problem I want you to do is this. I want you to take a sheet of paper. All right, I want you to cut it in half like this. All right, and you need to measure everything. Make sure you measure it accurately. And, oops, I'm sorry. Let's do it differently. I'm sorry. Let's erase that part again. I want this part to done. Fold it in half. Okay? And make that a triangle there. And cut this in half. And then make this into 3 equal pieces there. All right, so I want you to find the area of all those things. I'm going to know what those numbers are because I'm going to take a normal sheet of paper and I'm going to do it too. You need to be as close as what I'm going to have it, okay? Do the best you can. And then I want you to tell me the probability of flipping a coin, or not flipping, tossing a coin onto the sheet and getting, having it land in this space right here. Okay? So you have to figure out what the probability of that is. All right? All right. So those 2 things for section 1. Now, section 2. Let's see. I want you to do a independent event and a dependent event. Okay, so here's what I want first. And if you don't have coins or something around the house, you can flip other things, all right? But it needs to be equally likely. Okay, don't flip a I don't know. Don't flip a plate or something like that that's not equally likely to land on one side or the other. All right, so, or a cup. That doesn't make any sense either. Flipping a water bottle. Oh, that would be a good one. We could do flipping a water bottle. You could do that. If you want to flip your water bottle 50 times, tell me how many you actually had where it set straight up like it normally does. You got to flip it 50 times, though. That'd be cool. All right, so independent and dependent events. Here's what I want you to do. Your independent event where one does not depend on the other. I want you to, and you can do anything. You can do cards. You can do coins. So if you do cards, I want you to find the probability that you draw an ace. Let's do 4 times. What's the probability that you draw 4 aces? Now, independent means you're putting the card back. Okay? So I actually want you to do that. I want you to draw a card, put it back in, write it down, put it back in the deck, shuffle the deck, and yeah, you got to make sure you shuffle it, and then draw again, write down what you got, put it back in the deck, shuffle it again, draw the next one, and put it back in the deck, draw it again. So you do it 4 times. You got to shuffle, make sure you shuffle each time, put it back in each time, and actually write down the 4 cards you drew. But you also need to tell me what the actual probability for drawing 4 aces independently of each other. Okay? And you'll need your calculator for that. Now, the coins, you can flip the coins. I want you to flip your coin. Instead of flipping the coins, you can do the water bottle, okay? I think that would be a blast to see what you do 50 times, all right? But I want the probability... I'm sorry, I don't even want the probability. Just flip it 50 times and just tell me how many times you got it to stay. All right. So you do cards, you could do the water bottle, you could do. I want you to flip your coin 50 times. And what's the probability that you get 25 heads? All right. So they're independent of each other. Those are independent events. But you got to do the calculation and then actually flip it and tell me what you get. Now, dependent. Here's what I want you to do for dependent. So you really only have 4 problems to do for this. I know the video is long, but you got 3 days to do this. The dependent event here. I want you can use coins, 10 coins, grab 10 coins and put them in random coins, not all the same coins, okay? Pennies, dimes, nickels, and stuff like that. And what I want you to do, so for coins, okay, sorry, I was interrupted. So take a whole bunch of coins, put them in a bag or a jar or a bowl or something, or it doesn't have to be coins. You can take a piece of paper and color sections of it and cut them up, make them all the same amount of segments and put them in a bowl, and you can draw them, okay? So you don't have to have everything that I'm saying here. To be creative with this stuff, all right? So the point is that you know how many of each color you have, you know how many of each coins you have. And so what you're going to do is you're going to do the probability. I'm just going to use coins for this one. The probability of drawing a nickel and then a quarter, all right? And you're not, this is without replacement, okay? So first of all, you got to show me on paper how you did it, and then you actually do this. Really simple. Just draw one, and then you don't put it back, and then you draw another one, all right? And write down what you actually got. All right, so that's a dependent event. You could, again, you could draw cards. So another possibility is, let's see, you probably drawing a heart and a king. Now think about that. The probability of drawing a heart is a certain amount without replacement. Okay, you don't replace the first one, and then the probability of drawing a king out of the cards that you have left. All right, so you can do that, and then actually do that. Do 2 draws and see what you get and show me what you got. So that's your assignment. 4 easy problems to do, and have a great time. Next week is our last week, and I want to kind of keep doing this type of thing and end strong. So have a great week this week. Get these problems to me. Again, if you have questions, give them to me before noon on Wednesday, and I'll answer those questions you might have. sometime Wednesday, and then Thursday, this is all due to me by 2:30 on Thursday. Please don't wait till Thursday to do this. This is a really simple thing to do. Have a great week.